Okay, so in the previous classes of compound interest, we were seeing that if the interest is given to you, how the other values we can calculate. That was principal, rate, time. So we saw to calculate the principal, we saw to calculate the rate. Today we will see how to calculate n. I think someone's
N is the
screen is
time.
glitching. Yes, n is the time. Okay, how do we calculate the time period? That we are going to see today. So for that, let's take a question.
Okay, good.
Okay, let's take a question. In what period please check whose pen is glitching on the screen. Please check. In what period, at the rate of 10%, clearly the principal rupees 800 becomes, please don't use the red marker. $926.10 when interest is compounded.
Is it annually?
Simran, this is half yearly. Okay, this is half yearly.
Because it was
Ma'am, every
lagging
single
slightly,
question
so I
is
could.
half yearly, ma'am.
Sorry.
Ma'am, every single question here is half yearly.
No, some are annually also, quarterly also.
But that's only one.
That's only one. If you're gonna try the exercises, all types of questions are given to you. The half yearly, annually, and quarterly. Please don't write anything on the screen. I'm repeating. Whoever's marker is working on it, please don't.
Not me.
Okay. So in this question, we are having amount that is 926.10. Principal is 800. I'm writing all the values.
Ma'am, will it be R by 2 by 100?
R by 2 by 100. Yes, it will be R by 2 by 100. Okay. So amounts I'm given 926.10. Principal I'm given 800. Rate is 10%. That will become 5%. Why? Because we are compounding half yearly. So 10 by 2, that is 5%. Okay. Then, and we have to calculate. Okay. So amount formula we are going to use. amount formula, which goes like this. Principle 1 plus r by 2 we already did. So r by 100 raised to the power 2n. Oh, n, okay? Because n we don't know. N we don't know. That we are calculating. So let's put on the values 9,
Mom, you
10.
don't have n, you're saying?
Yes, n we don't know. Okay, that is the time period, okay, that we are calculating in this question, that we don't know. So 926.10 equals to, principal is 800, 800, 1 plus rate is 5, 500, raised to the power n. Okay, write n as it is because n we don't know. Okay, now here I have a point and I can remove this. I can remove this. So it becomes 92610 divided by 100. Okay, because I removed and after the point 2 digits, so 2 zeros. Then 92610 and 100. I can cancel the zeros like this, 0 and 0. I can cancel. Okay, now next step, 10 and 800. I can cross multiply. Okay, when we have values written like this, we can cross multiply them. Okay, we can cross multiply them. So I will cross multiply. So it becomes 92610. Sorry, 9261 divided, because 0 is cancelled. So 9261 divided by 10 into 800. 10 into 800 is how much? 8,000. So 9261 divided by 8,000, because 10 into 800 I did, equals to, now this portion I'm left with 1 plus 5 by 100 raised to the power n. This portion I'm left with 1 plus 5 by 100 raised to the power n. Okay. Now, see guys, now, yes, Abraham.
How did you cross multiply?
How did I cross multiply? I
How did you do
multiplied.
with 80?
When you are having values written like this on this side and equals to, you can multiply the denominator of this side with the numerator of this side, okay? Or the denominator of this side with the numerator of this side, okay? Like this, you can cross multiply them, okay? So I cross multiply 10 and 800. Okay, then see now, because this side and this side are equal, so it is possible that they might carry the same powers. Okay, but how do we make it in such a way? Okay, to find out n. See, look carefully. This is a bit different. 9261 and 8,000. I will take its HCF factorization. I will do. Okay, why? Because I will either make it a square root, I will either make it a square root or cube root.
I didn't understand this.
You didn't understand? I will explain. This side, okay, both of 9261 and 8,000, I will do factorization, okay? And then I will see that if if it will become a square root or a cube root. Okay, so I'm showing you the working over here. I'm showing you the working. See, 9. Let's do first with 9 to
So you
6.
like reduced it,
Yes, we reduce it.
simplified it.
9 to 6. Simplify it. Okay. So with 2 it will not be possible. So I'll do with 3. Do it with 3. You guys can try this out. We've already learned how to do factorization.
Ma'am, 21.
Very good. 21. 7, 9, 7, 7, 7, and 1. Okay. Then, if I try to make pairs of 2, okay, because when we are doing for square root with factorization method, we make pairs of 2.
Ma'am, it's
So if I
cube
make,
root.
yes, so if I make pairs of, it will not be possible, okay? Because
And isn't it 926.1?
926, no, Simeon, we removed the point. It was 926.10. We removed the point and put 100 in the denominator. When we cross multiplied it, the 0 and 0 we cut. When we cross
But
multiplied
how
to
did
get
you remove the point? Like on what basis?
on what base? See, when we are having a decimal number, suppose 234.8. Okay, I have to remove the decimal point. Okay, when I have to remove the decimal point, I will first see how many digits are there after the decimal. See, there is one digit. So when you remove the point, you put by 10, 10 after 1. Okay. If it was like 84, that is 2 digits after the decimal, it would have been remove the point and you put 100, 2 zeros, because 2 digits are there after the decimal. If there were 3 digits, you would have done upon 1000. Okay, that's how you remove the decimal. Okay, you divide it with either unit or hundreds, unit or tens or hundreds, like that. Okay, or thousands. That's how you do, depending on the decimal places after the point. Okay, so coming back to the factorization. Yes. So 9261. Because pair of 2 is not forming, we will make pairs of 3. 3, 3, 3, and 7, 7, 7. Okay. So I have 3 into 7. I have 3 into 7. 21. Okay. So 21 is the cube root of 9261. Okay. This is the cube root of 9261. Now let's do the factorization of 8000. I'm doing the factorization of 8000 to 4000 to 2000, then to 1000, then again to 500, then again to 250, then we can take again to 125, then 5. 25 times 125, so 25, then 5, 5 are 25, 5 and 1. Okay, now make pairs again, because again it is not forming pairs of 2, 2, we will make pairs of 3, 3. Okay, square root is not possible because both of them are not perfect squares. Okay, so we are doing cube roots. So let's make pair
Ma'am.
of 3. Yes, Edric.
Ma'am, there is a rule for perfect squares, ma'am. Ma'am, if it has an odd number of zeros at the end, it is not a perfect square.
Ma'am, the answer is 20.
Yes. Okay. Very good, Edric and Anaya. Answer is, for this one, is 2 into 2 into 5. That is 20. 20. Okay. So now we will proceed to our next step. Okay. What's the next step? Very simple. You are getting 21 cube for 9261 and 20 cube for 8000. So just replace 9261 with 21 and 8000 with 20 whole power 3. Okay, whole power 3, because both of them are cubes of these two numbers. I'm writing it here and showing you. It will be 21 by 20
Ma'am.
whole part 3. Yes, equals to.
Ma'am, the answer is 1.5 years.
Yes, very good. 1.5 years is the answer. Okay. N. Now solve. We have solved the left side. Now solve the right side. Okay. Very simple. We know how to solve the right side. Take the LCM. Okay. And solve the right side. Tell me what are you getting on the right side? Shall I erase the
Ma'am, it's
factorization?
21 by 20 equals to 21 by 20.
Very good, Amaya. It's 21 by 20. Okay. Shall I erase the factorization? If you guys have written it.
Ma'am, can you just explain me what was happening, ma'am? Since my the whiteboard started to fluctuate, ma'am, and whenever I would see it, some parts were not there, so I had to log out and log in. Can you just explain me, ma'am, what happened, ma'am?
What happened? Sure. See, Abraham. Till here you got? Till here?
Yes, ma'am. I logged out after the factorization.
Oh, okay. So factorization we did. Okay, we did the factorization. We found out the cube root of 9261 and 8000. Now, when we have the cube root, okay, we can replace 9261 with 21 cube. Okay, because it's its cube root. So you can replace 96.1 with 21 cube. And you can replace 8000 with 20 cube in this step. Okay. And then you gotta solve this step. So it becomes on the right side. That is 1 plus 5 by 100 raised to the power m. Take LCM, solve it. It becomes like this. 21 by 20 cube equals to 21 by 20 raised to the power n. Okay, raised to the power n. So now, here also on the right and left side are becoming equal. Okay, 21 by 20 on both the sides. Okay, now, because it's equal here and here, the power will also be equal, okay? This is the rule to this too. The power of the right side will be equal. So my n will be equal to 3. Okay, my n will be equal to 3. Now, this is compounded. This is for annual. Okay, and it is compounded half yearly. Okay, so for half yearly, divide 3 by 2. Okay, so it becomes 1.5.
I didn't understand that part. If you divide it by,
Yes, I mean, tell me what did you don't get? Then got.
no, I got it.
Got it? Okay.
Yeah, I
So,
just got confused.
okay, no problem. So this 3 is for
So n
annual.
equals to 1.5 year.
Yes. N equals to 1.5 year for the
Ma'am,
half year. Yes, Edric.
ma'am, you wrote a sad face below 3x.
No, that's equals to a bracket, but she erased one part and she didn't erase the rest.
Sad.
That's right. That's right. It was equals to in bracket. Abraham, is it clear?
Yes, ma'am. Thank you.
Okay, very good. So just let me know when you all have copies. We'll move to the next part.
Done, ma'am.
Done,
Done?
ma'am.
Finish
Okay.
copying, ma'am.
I've
Okay.
copied.
Okay, very good. So now see guys, now this is a very important part. I want you all to listen very carefully. Sometimes what happens that when we are making investments, okay, now two types of interests are there, right? Compound
SI and
interest
CI.
and yes, simple interest, okay, SI and CI. Now, how do we know that if we should go for SI or we should go for CI? Okay, how should we know? How do we know that if SI will give us more interest or CI will give us more interest. Okay, so you have to calculate both of them, SI and CI. Okay,
In
SI with
CI,
the
the value is always greater, right?
yes, in CI the value is always greater, but you have some questions in which you compare. Okay, that by how much the return of your CI will be more than SI. Okay, that how much the compound interest will be more than your simple interest. All right, that comparison we should know how to make. So we have question on that thing that how we are going to make comparison. Same values will be given, but different methods we will use. Okay. For the simple interest, we use simple interest formula P into R into T by 100. For compound interest, we use compound interest formula. That is first calculate amount, then from that subtract your principal to find out the compound interest, and then you do compound interest minus simple interest to see that how much more you are getting in compound interest. Okay, that's what we are going to try out right. Okay, difference between compound interest and simple interest. Okay, let's check out one question on this on the difference between compound interest and simple interest. Okay, so here goes my question. Find the difference between
So in that difference, you will have to see the, is it like a percentage or like just the amount?
just the amounts only, just the amount, okay? In this question, with same values, you have to calculate first SI and CI both. CI, SI and then CI both. With same values, okay? Principal will be the same, R will be the same, T will be the same. Everything will be the same. Only two methods, both methods you have to apply and then find out the difference. Okay? CI and SI for rupees 48,000 for 3 years. This is my principal.
Ma'am, I can't find anything written on the screen.
It
Is
is
it visible to the others? Is it visible? Edric Abraham Sandhu?
It is.
Okay. And I will just check your network real quick.
Okay, now I'm able to see it. Actually, my screen was a little below.
Okay, no problem.
Now, if you're not able to see it, try zooming out and then you may see a red icon. That's the
No, I was able to see. I'm able to see it, Abraham. Thank you.
And when interest is compounded annually, okay, this is the question where your CI will be compounded annually. Okay, so we're having principal. My rate is 5%. Time is 3 years. Okay, so first calculate SI. SI equals to principal into rate into time divided by 100. So 48,000 multiplied by 5 multiplied by 3 divided by 100 cancels zeros with zeros. 480 into 5 into 3. Multiply them. 7,200 rupees. Okay. 7,200 rupees. So I have my SI. Now we will calculate CI. Okay, for the CI amount formula, we will use amount first equals to P 1 plus R upon 100 raised to the power N. Put the values 48,000 1 plus what's R? 500. What's N? 3 years. 3. Okay, now solve this. So 1 plus 5 by 100 becomes 21 by 20. Okay, because it becomes 100 plus 105 by 100. So 105 by 100 cancel by 5 becomes 21 by 20. So 48,000 raised to the power 3 means 21 by 20 will come 3 times. So write it 3 times 21 by 20 into 21 by 20 into 21 by 20. Now cancel the zeros of all the 20s. It's 48,000. Now cancel more. 2 ones are 2. 48 cancel 48 with 2. 2 twos are and 2 fours are 24. Then 1, 2 ones are 2. 24 reduce it. 2 ones are 2. 2 twos are 4. 12 we have. Then cancel with the next 2. 2 ones are 2.
Ma'am, 6, ma'am.
Yes, 6 as 1. Okay, now multiply 6 with 21 and 21 and 21. Multiply them all. You will get 55,566. Okay, so this is my amount. Now calculate compound interest, that is A minus B. CI compound interest equals to A minus B. So 55,566 minus how much? 48,000, which is my principal. 48,000 subtracted, I will get 7,566. 7,566 is my CI. Okay, now let's deduct. This is 7,200 SI. Okay, now find the difference. Difference is
Ma'am, 366 rupees.
yes, very good, Anaya. Compound interest minus simple interest. So compound interest is 7,566 minus 7,200, which comes to 366 rupees. Okay. Hope this question is clear to you.
Yes, ma'am. Done, ma'am.
Okay. Okay, Abraham. Samir, done?
Yes.
Okay. Very good. So whenever finding the difference, whenever question comes, tells you to find the difference between CI and SI, just take the same values, okay? Calculate SI with the SI formula, CI with the CI formula, the amount formula and the CI formula. And then you will have SI, you will have CI. Do compound interest minus simple interest to get the difference. Okay, very simple. In only thing is that you are going to do the same question with two methods, both the methods. Okay, that's the only thing. That's how you can find the difference. Okay, now I'm clearing the screen. Now, guys, see, there is one more concept. Okay, this is the last concept of this chapter. Okay, now what happens right now we were finding the difference. We were finding the difference and with the CI and SI. Now what can also happen is this, that sometimes you are given the difference. Okay, you are given the difference. With that difference, you have to calculate other values, that is principal rate or time. Okay, with that difference, you gotta calculate other values. So in your syllabus, um, only principal is given. Like when difference is given, okay, R and N will be given. T you have to calculate. T you have to calculate. Okay, this thing is there. So this thing also we will learn. Okay, how do we use the difference to find out principal? Okay, the difference between CISI, how we use that difference to find the principal. Okay, for this I'm teaching you a formula. Okay, for this I will show you a formula. Okay, one question we will do, and with that question I will teach you one formula. Whenever such type of questions come, you can find it out. Okay, on a certain sum of money. Please check. Someone's device is making lines. Again, let's see. On a certain sum of money, the difference between CI and SI, the difference between compound interest and simple interest is rupees 16 at the rate of 10% annual. At the rate of 10% annual in 2 years. In 2 years. Find the principal. Find the principal.
Ma'am,
Okay. Yes, Edward.
ma'am, how do we know if the compound interest is compounded yearly, half yearly, or quarterly?
How we know that? Annual is written here. Look, annual word is written. Means it's compounded annually. Okay.
And it's
It
not
will be
given
mentioned.
total.
It's not given the
Total amount of time.
2 years. It's given. Okay. 2
Oh,
years. Yes. Okay. So we have the difference. I'm writing the values that we have. Okay. Difference between CI and SI, rupees 60, rate, that is R, 10%, and time, 2 years. Okay. Now the formula that I'm going to show you is derived out of simple interest and compound interest formulas. Okay. That formula is derived out of simple interest and compound interest formulas. How does that work? I'll show you. Okay. So this is my formula. Difference equals to principal multiplied by rate by 100 raised to the power n. This is for annual. Okay. Annual. But we know how to we modify it if it is for half yearly or quarterly. If it is quarterly, just put r by 2 and here 2n. If
Ma'am,
it is, sorry,
ma'am, that's
half
for
yearly.
half yearly.
Half yearly, yes. Yes, half yearly. If it is half yearly, put r by 2 raised to the power 2n. If it is for quarterly, put r by 4 raised to the power here 4n. Okay, here 4n. So the same formula will be used in every difference question. Okay, when you're given the difference and you are asked to find the principal, this formula will be applied. Okay, now what do we do in this formula? How we solved it? Let's see. This is annual, so we are just having r by 100 raised to the power n. Put the value of difference below difference. Okay, 16 is my difference, so put 16 here. 16 equals p. I don't know, so p write as it is. Write p as it is. Multiplied by r I know is 10. Put r 10 by 100. In my time I know is 2 years. So put 2 here. Okay, 2 years. So put 2 here. Now cancel. Cancel. First we will open it. Okay, that is 16 t into, because raised to the power 2, let's open 10 upon 100 into 10 upon 100. Cancel all the zeros. 0 with 0 and 0 with 0. So I have 1 by 100. Okay, I have 1 by 100. So here I'm writing 16 equals to t into 1 by 100.
Ma'am, 16
Okay.
equal to p by 100.
Yes, we'll get to that. So now p into 1 is p. Okay. 1p we don't write. So 16 is equals to p by 100. This way also you can solve. So now you can cross multiply 16 and 100.
Ma'am, p
Then
equal to p equal
yes, we cross multiply 16 and 100 of the p, that is
Ma'am,
denominator.
1600.
Yes, and this numerator. Okay, so I'll write it like this. P equals to 16 into 100. P equals to 1600. Okay, like this. Okay, so that is how we find the value of your principal. Okay, very simple. Just use this formula. Okay, just use this formula. Okay, this is for annual. This is for annual. And it's compounded annually. Okay, first copy this and then I'll write for all the three, half yearly and quarterly. Okay. Nothing you have to
Done,
do.
ma'am.
Done. Okay. Same formula. Okay. If it's half yearly, just do r by 2 and then whole square में do 2n. Okay. If it is quarterly, just do r by 4 and then in whole square do 4n. Okay, like that. That you have to adjust, okay, according to the compounding. Else the whole thing remains the same. Okay, this is different formula, very easy method. In the book there is a harder method, but this is a simple method. Okay, quick and simple method you can follow. Okay, I hope this is clear now.
Yes, ma'am.
Any thought? Okay, any doubt you can ask me. Tomorrow problem class of this chapter I'll be taking. Okay, so please complete all the 6 exercises. That is till 9.6. Okay, 9.5 and 6 are homework for today. Complete this chapter.
Ma'am, what is the homework? 9 point?
5 and 6.
But did we have it on 9.4, ma'am, before?
Yes, I had given 9.4 as homework before.
No, ma'am.
So No,
Ma'am, today
I
can we do
remember giving.
9.4 only?
I remember giving it. No
No,
problem.
ma'am, you
I'll
haven't
pick it.
given it, ma'am. You've given 9.3 last. Because
Yeah.
what we've done is the extra classes, the backup classes.
Okay. So do 9.4 today. Tomorrow do 9.5 instead. Okay.
Okay.
So yes. So shall I take the doubts till 9.4 tomorrow, or shall I take the doubts of the whole chapter on Wednesday?
But on Wednesday we have some other class, right? Some other test, ma'am, right?
Wednesday, you people are having science test. Math class will be there, regular.
Okay. Yeah, then ma'am, can you take just till 9.4 tomorrow?
Okay. So doubt class of till 9.4 tomorrow. 9 till 9.4, 9.1 to 9.4 tomorrow. Okay. And on Wednesday, 9.5 and 9.6 doubt class. Okay.
Okay, ma'am.
Clear everyone, but by Tuesday, okay, or by Wednesday before class, please finish up this chapter. Okay. Wednesday, I'll take the doubts of 9.5 pencils. All the doubts. Will wrap up this chapter and I'll give you the answers of the doubts. Okay. Yes. So we'll begin with a new chapter after that. So that's
When,
all
ma'am?
for the math class. After the doubts of these chapters are clear.
Ma'am, Thursday, ma'am?
Yes, probably Thursday. Okay, or Wednesday. I'll see. If the doubts are cleared by Wednesday, we can start legislating. Okay, ma'am.
Excuse me, ma'am.
Yes, ma'am.
On Wednesday you're giving the science test, right?
Wednesday, science test. Yes.
I won't be able to do it until 7 o'clock because on Wednesdays I have music classes and we are going to be out for 2 hours, so that's why I won't be able to do it till until 7 o'clock it is.
Okay.
So
So
I
no
might have to send
problem.
my paper a little later. Is that fine?
It's fine. It's fine. You can start with 7 by 7 or 7:30. Okay. Take whatever time limit I'll be giving, and then after that, after you finish, you can just join. No
Okay,
problem.
ma'am. Thank you.
Okay, then that's all for the math class
Bye,
today. Bye,
ma'am.
Andrew. See you tomorrow. Bye. Yes. So, Simeon, you weren't there on Saturday, no?
Yeah, but I
Simeon,
listened to the class already.
you listen? Very, Saturday class I haven't uploaded, Simeon, on YouTube. I will
Oh,
upload it today.
Saturday class. I meant the Friday class.
Yeah, Saturday class I'll upload it today. This class and Saturday class. Okay. So, Simeon, we're planning for a science quiz. Okay.
I
A
didn't
science quiz.
understand. What?
A science quiz. Okay. On the materials chapters. Two chapters are there of materials. Okay. And on both the chapters, we are planning for science quiz. Okay.
Is it a
And
test or something?
it's not a written test. It is the oral. Okay. Verbal. Oral. That is, I'll be asking questions. There'll be rounds. I'm planning for 3 rounds. Okay. All the information. And once it is planned out totally, I will share it on the group and I'll share it in the class also. Okay.
Okay.
Next, yes. This week you are having test of biological processes one. Okay, on Friday and sorry, Wednesday biological processes one. Then next week your quiz is there. Okay. Next week quiz on materials part one and materials part two is there. Both the chapters. Okay, and then after that, in the next to next week, I'm keeping a mega test of biological processes 1 and 2, both chapters together. Okay, both chapters together. You still have a lot of time, 2.5 weeks you'll be having for that test. Okay, two chapters, biological processes 1 and 2, both will be coming. Okay, it will be
And
a
ma'am,
big.
this week what chapter do we have?
This week we have biological processes 1 in science.
Okay, thank you.
Yeah. Next week quiz, and after that, the next week after the quiz, we have the mega test in science. That's biological processes 1 and 2 tests. Okay. Okay. 2 minutes break, Sumian, till 3:50. Okay. I can go and quickly be back. Hello. Hope you guys are there. Abraham, hope you are there too.
Yes, ma'am.
Okay, perfect. So this is the second chapter on materials that we are going to start now. Okay. On in the last class we finished up with the types of materials 1. This is types of materials 2. Okay, both the chapters will be there in quiz. Okay, both of them will be there in your quiz. So let's begin with it. In our daily lives, we people use a lot of things. We use a variety of things such as utensils, chairs, bicycles, mobiles, etc. A lot of things in our daily lives and everything we use. Okay, now these things are made up of different types of substances that we are going to study about. Okay, different types of materials, different types of substances they are made up of. Okay. Now, some things are made up of, like basically, when we talk about things, they are made up of either metal or non-metal. Okay. They are, they can be classified on these two bases. Okay. That's metals and non-metals. Okay. And when we talk about materials, some of them are found in the Earth's rocks naturally as minerals, and others are made by human beings in factories and industrial units. Okay, so now we'll talk about minerals, we'll talk about metals, non-metals, all of them. Okay, so if we talk about minerals, there are 89 types of minerals found in India. Okay, now minerals, naturally occurring minerals, can be metallic or non-metallic. Okay, can be metallic or non-metallic. Now, out of the 89, 11 are metallic, 11 are metallic, 52 are non-metallic, 4 are pure minerals, and 22 are other minerals. Okay, we get metals from metallic mineral. They are also called ore. Okay, ore means metallic mineral, okay, which is also called ore. And from that, when it's processed, refined, we get metals. Okay, from that we get metals. The minerals from which metals can be extracted profitably and conveniently are known as ores. This table shows metallic ores and their location. Okay, so iron metal comes from hematite and magnetite ores. Okay, from the ores of hematite and magnetite. And these ores of hematite and magnetite are found where? In MP, Karnataka, Bihar, Orissa, and Tamil Nadu. Okay, then we have copper. Copper metal is derived from pyrite ore. Okay, from pyrite ore. And where this ore is found? This is found in the places of Rajasthan, Bihar, MP, Andhra Pradesh. Then we have aluminium metal, which is derived from bauxite ore. Okay, and this bauxite ore is found in MP, Odisha, Gujarat, Bihar, Andhra Pradesh, and Maharashtra. Okay, then we have manganese, which is derived from pyrolusite ore. Okay, which is found in Karnataka, MP, Odisha, Maharashtra, and Gujarat. Then gold. Okay, this exists in free state, means there is no such ore to it. Okay, it exists in free state. Okay, this is actually refined. Okay, it doesn't come from an ore. You don't have to extract it from an ore. It is there in mines. Okay, but we refine it, process it. Okay, then this is found in Karnataka, Andhra Pradesh, etc. Okay, then there are non-metallic minerals. Okay, these are non-metallic minerals from which metals are not extracted. Okay, from which metals are not extracted because they are non-metallic minerals. There's mica, okay, or mica. It's found in Bihar, Orissa, Tamil Nadu, Rajasthan, Andhra Pradesh, Gujarat. Then there's limestone, which is again found out in MP, Andhra Pradesh, Rajasthan, Gujarat, Karnataka, Bihar, Orissa, Tamil Nadu, dolomite, found in Madhya Pradesh, Gujarat, Karnataka, West Bengal, Maharashtra, Uttar Pradesh, Orissa. Then gypsum, that's found in Rajasthan, Jammu Kashmir, Uttar Pradesh, Tamil Nadu, Gujarat, and asbestos, that's found in Karnataka, Bihar, and Rajasthan. Okay, these are all types of minerals which are non-metallic. Okay, yes, and
I was just saying that a lot of minerals are being found in Karnataka.
yes, a lot of them are found in Karnataka, Orissa, and MP also. Right. So then we have metals and non-metals. Okay. You are familiar with a number of materials which are metals like iron, copper, and gold. You also use them in your daily life. Similarly, you are familiar with many non-metals and their uses like mica, sulfur, coal, oxygen gas, etc. Okay, this activity you can try out. You can put the item here and you can put the material it's made of. Okay, so then, like you can put a name of a utensil, you can put what it's made of, steel or copper or aluminium. Okay, like this, you can try it. Then we have physical and chemical properties of metals and non-metals. How do we know that something is a metal? Okay, or how do we know that something is a non-metal? So metals have some qualities, okay? They're having some qualities with which we can tell that it's a metal. Similarly, non-metals have some qualities and characteristics with which we can tell that it's a non-metal. So that's what we're going to talk about, physical and chemical properties of metals and non-metals. Okay, so this is first the qualities of metals we are going to talk about. Metals are lustrous. They have specific metallic luster. Do you know what's luster? Shiny
Yes,
surface?
ma'am. Luster is the shiny property in many metals and minerals.
Yes, very good. It is a shiny property. Okay, its surface is shiny, okay, of the metals. They are generally hard, but some metals like sodium, magnesium are so soft that they can be cut with a knife. Okay, this is exception to this property that metals are generally hard, but some metals are there which are exception, which are soft, okay, soft metals, okay, which are sodium and magnesium. Okay, sometimes this question is asked, okay, that what are the soft metals? Okay, so they are sodium, magnesium. Then metals can be beaten into thin sheets. You might have seen a blacksmith beating an iron piece to make iron articles like a spade, a shovel, etc. So, it can be beaten, okay, to give it shape, okay, to make various things such as a spade, a shovel, etc. Okay, can be beaten into sheets. Okay, then what will happen if you beat a piece of wood? Thin sheets are made by beating aluminium. Chocolate, toffee, and medicines can be kept safely in aluminium foils. If you have seen the aluminium foils of chocolate, toffee, medicines, okay, they are sheet-like, right? If you've seen the medicines of that come in a like completely silver wrapping, you've seen that. So it's talking about it. Now you might be familiar with silver foil used for decorating sweets. Property of metals by which they can be beaten into thin sheets is called malleability. Okay, this is important. The property of metals by which they can be beaten into thin sheets is called malleability. Means you can beat it, make a sheet out. Okay, you can beat it and make it into a sheet is known as malleability. Known as malleable means can be beaten, made into a sheet. Okay, then it is a characteristic property of metal. Metal can be drawn into wires. Yes, they can be drawn into wires also. Okay. Now, when metals are drawn into wires, this is known as ductility. Okay. Ductility. All right. Um, this is again important. Okay. What it is called, what that property is called of metal when they are being drawn into wires, ductility. Wires made of copper and aluminium are used to conduct electricity. Okay, because they are good conductors of electricity. They are used to conduct electricity. Metals are good conductors of electricity. Okay, this is why our wires, okay, the wires that we use are mostly made up of metal because they are good conductor of electricity. They allow to pass electricity through them easily. Metals get hot quickly because they are good conductors of heat. Okay, they are also good conductors of heat. This is the reason they are used to make cooking utensils. Okay, this is why cooking utensils are made up of metals. Okay, then metals are solid and strong, so they are used for making buildings, trains, machines, fridges, vehicles, etc. Okay, solid and strong. The things made of metals produce ringing sound when struck against a hard surface. Suppose you have two objects in similar in appearance, one of wood and other of metal. Can you tell which object is made of metal by striking both the objects? Since metals produce ringing sounds, they are said to be sonorous. Okay, this property that metals, when they are banged, okay, against the surface, they produce a ringing sound. This is known as sonorous. Okay, means producing sound. Okay, so three terms that we learned in the characteristics of minerals are malleability, they can be beaten to shapes, ductility, they can be drawn to wires, and sonorous. Okay, these are the main keywords. Okay, when you are answering in oral or in written paper, it's very important that you people use these three words. Okay, malleability, ductility, and sonorous. Okay, very important to use these keywords. All right. So we saw a lot of properties of metals. Okay. By when an object is said to have all these qualities, it can be considered that that object is a metal. Okay. Exceptions to the characteristic of metal that metals are hard is, what are the exceptions? Sodium and magnesium. Okay, those are the soft metals. Metals, but soft. Exception to the quality that metals are hard. Okay, then after considering the above properties, we can say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. This is the characteristics of metal in short. The materials which generally possess these properties are called metals. Okay, they generally possess these qualities are known as metals. What are the examples of metals? Iron, copper, aluminium, calcium, magnesium, etc. Okay, these are all metals. Metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is found in liquid state at room temperature. Okay, again, this is very important. What is the metal that is found at room temperature in liquid state? Okay, mercury. Okay, in room temperature, that is a normal temperature, it is found in liquid state. So this can be asked as a short question. Okay, it's important. Okay, then in contrast, materials like coal and sulfur are soft and dull in appearance. They break down into powdery mass on tapping with hammer. They are not sonorous and are poor conductors of heat and electricity. Okay, now sulfur and coal. What happens to sulfur and coal? Okay, if you've ever pressed a piece of coal like this, it becomes powdery, black powder. Right, so, and it's not hard, it's not shiny, okay, it's not, if you put it, bang it against the surface, it will break, it will produce no sound, okay, it won't produce a sound, okay, and they are poor conductor of heat and electricity as well. So they are what? Non-metals, okay, they are non-metals. The materials which possess these properties are called non-metals. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. Okay, these are all non-metals. Then Chemical properties of metals and nonmetals. Chemical properties of metals include reaction with air, water, acids, which means what are the effects of water, air, acid, etc. on metal? Okay. Now, chemical properties means that what will be the effect of air, of water, of acids on a metal? Okay, that will tell you its chemical property. Okay, that the reaction it will produce is my chemical property of metals. Okay, so what happens when metals, when we have to see its reaction with air? So metals react with oxygen. Rusting of iron is an example of such reaction. Okay. Now, what happens? Why do iron rusts? Okay. Like why rusting takes place on iron? Because iron, okay, when it reacts with oxygen and water, the rust is formed on its surface. Okay. The rust is formed on its surface. That's how rust is formed. That's how it reacts with air. Okay. The oxygen in the air and water to form rust on its surface. Okay. Then this is an activity. You guys can read it at home today. Okay, 7.2. Okay. When copper vessel is exposed to moist air for long, it acquires a dull green coating. A dull green coating. The green material is a mixture of copper hydroxide and copper carbonate, which is formed due to reaction of copper with oxygen and water.
So
Okay.
after that, can you remove the green coating?
Can you remove the green coating? There are some methods, yes, to
Like, is
remove the
it
green
something to
coating.
peel off, or is it like
No,
the copper changes the color?
the copper changes the color, Sunil. It's not a peel, okay? It's not a peel. If you scrub it hard, okay, some people try to produce another chemical reaction, okay? Like for the cleansing, I've heard that people mix lemon with baking soda or baking powder and lemon, and then scrub the corroding with that, okay, the rust or the green thing with that to cleanse the surface of the metal. Okay, so another reaction they try to use to cleanse that surface. All right, another acidic reaction. So, yes, if you like use some with some reactions, some efforts, it can be erased, removed. Okay, but not very easily. Not very easily. It's not simple. Okay, because it literally happens in the surface of it. Literally, it's not a peel. Okay, it's not something that lies on it. It happens to surface itself of the metal. So it's not easy to remove. Okay, it's not easy to get rid of. All right. So um, copper vessel. What color is the copper vessel? Have you all seen a copper vessel?
A copper vessel is a copper color,
Yes, copper color, brownish and copper color.
kind of
Yes,
maroon.
yes, kind of maroon and brownish kind of. So on that a green layer forms. Okay, and that layer forms due to the reaction of copper with oxygen. Okay, then in iron, rusting happens. Okay, rusting happens when yes, Abraham.
To remove the greenish layer, could we melt it? Could we melt the vessel? And
Can it be melted? No, it cannot be melted. Okay, we cannot melt the vessel.
oh, my I was asking, could you melt the vessel and then just like peel off the greenish layer after it becomes hot?
No, it doesn't happen like that. We
There was
cannot
a,
remove.
I saw a video once where there was this guy who collected a lot of rust and he put very little water in it, and the water turned kind of like a brown goo, and he poured it on a piece of he put a piece of metal, a chunk inside an aquarium, and he poured the goo over it. 5 hours later, it was completely gone.
The metal was completely gone.
Yeah.
Okay. I don't know the details of it, but that the goo kind of thing that he poured on it must have completely ate up the metal, completely destroyed it, I think. I don't know. Okay, so yes. We cannot because to melt the metal, very, very high degrees of temperature is needed, Abraham. Okay, it's melted literally in a furnace. Okay. So, and we cannot melt it on our gas or on our stove or on our burner. No. Okay. It needs a furnace, a whole structure of fire inside it, very high temperatures to melt it. Okay. So we
But
cannot do
once I put a metal patram inside the microwave by mistake, and I heated it, it changed shape afterwards.
it changed shape afterwards.
Yeah.
Yeah. So it will change shape, but to completely melt it, okay, that very high degree temperatures are needed.
500
Hopefully,
degrees Fahrenheit.
yes, yes, yeah.
Simran,
So that's how.
what type of metal did you put in the microwave?
What type of metal, Samir?
I'm not sure. I think it was stainless steel.
Oh,
Okay,
yes.
stainless. All right. So mostly your metals are good conductors of heat. Okay. And in the microwave, there are a particular type of utensils that you can use in the microwave. Not every utensil you can put it in. Okay.
One question, ma'am. If the metal is put in
Yes.
the microwave,
Like the
how did it change its shape? When the microwave blasted or something is because metals cannot deal with that type of radiation in the microwave. That's why
yeah,
you put a metal spoon or a metal fork in the plate when you're heating the food up.
but the plate became very hot, and because of the heat, it changed shape also. And afterwards, when I touched it, I couldn't take it out.
Mm-hmm.
So I had to wait for a lot of time.
Okay. Yes. So that's right. And what was I telling you? Yes. So some food also reacts with metal. Okay. Some food which has like acidic nature also reacts with metal. Have you ever heard your grandparents telling you or your parents telling you that don't make a lime water shikanji in copper vessel?
A
Have
what?
ever in a copper vessel to make
Not do what?
Don't
lime
think
water to make lime water shikanji or nimbu pani in copper vessels,
I didn't
copper
understand what you
aluminum.
said. Lime water, what?
No, she was saying that have you ever heard your grandparents or parents tell you never make lemonade or lime water or shikanji or something in copper vessels?
In
what is
copper or aluminum.
shikanji?
Shikanji is a Hindi word for lemonade.
So it's lemonade.
Yeah. Yes. So, because it reacts, the lemon, because it's acidic, reacts with the metal. Okay, it reacts with the metal, and it's like harmful for us to consume. Also, I think it's for milk also. I don't remember well. I have to ask my grandmother. So, I think it's for milk also. It like reacts with the food also. Okay, and also like very hot food you shouldn't directly pour it on foil. If you've heard this, you shouldn't directly put very hot food the the aluminum because it reacts with the heat. Okay, like that. So there are a lot of reactions that takes place. Okay, a lot of reactions in metals. Okay,
I
like
read
acid.
somewhere, I think it was in my science book, that where there was this guy who took a piece of sodium and he threw it in water and it caught fire.
And you've got fire, sodium.
Yeah.
Okay,
And they had to throw
okay.
very small pieces because Otherwise, it could burn the whole place down.
Hmm. Right. So when we were, it reminded me of that time when we were in, I think, 10th standard. We had our chemistry lab, and in that, I think some sodium or I don't know what metal, what this chemical pills are there, small white pills. We used to pick that up with the tongs. Small tongs were also lying there. We used to pick that up and throw it in the sink, and it used to like produce a small fire, small, very small fire, and a popping sound. Okay, and then we used to like play with it, throwing it in the chemistry lab sink. Okay, and it used to produce a small fire and a small popping sound in between the classes. So it's really bad in the chemistry lab, right? You guys have been in there, very
I've never
smelly.
gone to a chemistry lab.
Neither me,
Oh,
ma'am. Even gone.
okay, okay,
I've not gone to a chemistry lab, but I have like a chemistry like set type of thingy, so I have like done explosions and all that stuff.
okay. Wow. Yes. So it smells really bad in a chemistry lab. All the chemicals, it smells so bad, like unbreathable because all the chemicals smell so bad and so strong inside the chemistry lab. So, anyways, now metals react with water. Okay. So yes, this is what Simeon talked about. Sodium is metal is very reactive. It reacts vigorously with oxygen and water. Okay, and a lot of heat is generated in the reaction. Okay, sodium metal is very reactive and it reacts with oxygen and water, and a lot of heat is generated in that reaction. A lot of heat. So that's why it's stored in kerosene. Okay, so that it doesn't react directly with air or water. Okay, because it will, then a lot of heat will be generated. Okay, fire can take place. So it's stored in kerosene. Then generally, non-metals do not react with water, though they may be very reactive with air. Yes, Abraham.
Ma'am, potassium is also very reactive with water. That's why it has to be stored under oil.
Yes, potassium and all these metals are very reactive with water, but non-metals do not react with water, but they may be very reactive in air. For example, phosphorus is a very reactive non-metal. It catches fire if it's exposed to air. Okay, if phosphorus is exposed to air, it can catch fire. To prevent the contact of phosphorus with air, it is stored in water. Okay, so that it directly doesn't come in contact with air. These some of them are stored in kerosene, some of them are stored in water. Okay, non-metals generally do not react with acids, but metals react with acids and produce hydrogen gas that burns with a pop sound. I think this is what we people used to do. The story that I told you. This is what we people used to do. Produce hydrogen gas that burns with a pop sound. Okay. Some metals such as sodium, potassium, aluminium, copper, iron, etc. are highly reactive, but other metals such as gold, platinum are less reactive. Okay, these are less reactive metals. Yes, Abraham.
Ma'am, this when the metals react or some reaction takes place or with hydrogen or something, can it can it be a deadly thing like the smell or the gas produced?
Gas is produced when they react, heat is produced, okay? When that reaction takes place in metals with air or water, okay, the outcome, the reaction can be some gas, okay, the reaction can be the smell, okay, the reaction can be heat, okay, reaction can be heat, okay. These all can be, reaction can be pop-up sound, okay. pop sound also. So different kinds of reactions are there. Okay, when different kinds of metals they react, different kinds of reactions can take place. Yes, Abraham.
My question was, can the reaction be fatal?
Federal. What did
Fatal.
you say?
Saying fatal, ma'am.
Fatal, fatal. No, it's
Sometimes, right, ma'am?
generally not.
Sometimes.
Sometimes, if there's a like huge quantity of the this thing, chemical, at that time it can be fatal. Yes, if there is, it's done in like huge quantity. Okay, huge amount of gas, huge amount of chemicals, a whole factory, whole factory level. Okay, or like very highly reactive, very risky chemicals. That time it can be fatal. Like it can cause a huge blast, okay, fire blast. Like very like some dangerous chemicals are there that you should not mess with. Okay, because they are fatal. Okay, you can check out some case studies on it, such as there was the Bhopal gas tragedy and things related with it, in which like also there was some story I don't remember in which some factories were there with which like I think it discharged some chemical into the water and all the fishes of the water died. The people who drank it also, um, they were facing a lot of health issues. So I think that case study was also there. I'll share it with you. I'll search for it, okay, and I'll share it. Yes, Abraham. Anything else? Okay. So it can be fatal if we are very careless or if it happens with a lot of chemical. So this is your homework. 7.1 is your homework. Okay. Then uses of metals and non-metals. 7.3. This we will continue from tomorrow. Okay. We'll continue this in the next one. Okay. So please start preparing for the quiz. Okay. It's this chapter and the previous because that was a very short chapter. Okay. The previous one was a very short chapter, and both the types of materials chapters, the quiz will be there. Also, please focus on the terminologies, okay? The terms, main terms, such as decantation, sedimentation, main terminology, okay? So anything can be asked from you guys. And for the science test on Wednesday, please prepare all the diagrams well, okay? You guys can expect a lot of diagrams in the paper.
But ma'am, there weren't many diagrams in the past two lessons. There weren't too many.
Okay, but in biological processes, there are diagrams. I think 10 to 11 diagrams are there.
Yeah, biological processes are there, but not in this, no?
This one, no. In metals and non-metals, I'm not telling you. I think no, diagrams are not there in this chapter, I think.
Yeah.
So yes, so for the quiz, no diagrams. Okay, only the questions for the quiz, but for the test, diagrams will be there.
Ma'am, on Wednesday will be only biological process one, right, ma'am?
Wednesday, only biological process. Okay?
Only biological process one, right, ma'am?
Right, only
Okay.
the chapter. Okay, okay. And I'll see you guys tomorrow. Bye.
Okay, ma'am. Bye. Thank you.
Okay, okay, bye.
Bye.
Okay.